Yeah, so Mcity 2.0, major NSF funded initiative. We always need to be very grateful to NSF for the great championing they've done of this effort. Um, I made this list because this is what Mcity has become, right? I remember maybe 2 years ago, basically, when I came into Mcity, people would always say, "Oh, so you're going to be part of that test track, right?" So that was how Mcity was known. It's a physical test track on North Campus, right? And so I wanted to make this list to show you how much more than a test track it is, right? So the top line is the only line that's the physical test track, right? That top row. And, we do have new adverse weather generation capabilities. Snowmaking was added. I guess it's rainmaking now. So, when the temperatures get to 80 degrees, we have test platforms. We have, moving not only from the MKZ and the Mach-E, but into drones. Our test platform has RoboSense LiDARs on it. So thank you to RoboSense for that. We have a driving simulator. Thank you to VI Grade for that. It's in the Aux building right next to the track. And then we've been working an awful lot on this digital infrastructure, the digital overlay. So we right now have released our Carla digital twin. So that is open source now. Within about 2 weeks, our Omniverse digital twin will be out. And then we're going to talk to parallel domain here a little bit later on the agenda. We will have a parallel domain digital twin as well, released open source. And then we've got a really tight partnership with NVIDIA, because NVIDIA has made some high fidelity, physically accurate sensor models that we're integrating as well and doing some correlation work. The data engine we've been working on for continuously improving AI algorithms, as Greg said, we're going to make it into an agentic system to make it easier to use for people. And we have our compute cluster. We have 8 H100s. We have 8 NVIDIA L40Ss. And we're looking to double both of those because right now they're jammed. The GPUs are running constantly right now. We have an adversity orchestrator. Wade later today will tell us about that in a lot more detail. We have a cloud platform, thanks to our partner AWS for doing the data brokering. Thank you to Verizon for our high-speed connectivity on and off vehicles with the 5G ultra-wideband service we have. We can get data from our test vehicle onto the Amazon AWS backbone in 9 milliseconds. So that's really, really awesome. And then, we are using AutoWare as our sort of guinea pig test software for doing autonomous work. AutoWare releases their code open source. And then performance measurement. So how does what we do affect society? So we'll talk a lot this afternoon about our AV safety assessment. How good is good enough is one of the hardest questions that the AV world has needed to answer. And we are going to get into that conversation deeply. And we believe it's a societal conversation. It's not a Waymo decision. It's not a Tesla decision. It's societally, what is society willing to accept? And then Alex's work on the Transportation Security Index. Again, a nice way to measure sort of before and after effects. We identify a problem, we measure it, we put some autonomy in place, then we remeasure to see whether we've made, a significant impact. So a lot more than a physical test track, right? That's the main point. So now I'm going to just walk through the 10 projects that we have given the green light to this year as part of our Mcity 2.0 work. Basically, that was our commitment to NSF, was to sort of build all of this Mcity 2.0 infrastructure and then run projects to take innovators and sort of enable them to get their project work done more efficiently. Jeff Bond from the University of Washington is working. We've put controllers in the downtown Mcity intersections so that remotely from University of Washington, he can run his algorithms to control the signal phase and timing on our track, the physical track, so the physical lights on the track, as well as in the digital twin. And the work they're doing is trying to figure out how to optimize that signal phase and timing to get the largest number of vehicles through the intersections as efficiently and safely as possible. And so not only controlling when the traffic lights change their signal, but also, broadcasting out what speed vehicles should be going at in order to get the green phase when they get there. So that's our first project that we're doing. That's a University of Washington one. This one you'll hear more about this afternoon. So University of Buffalo has 3 simulators that they're connecting up to our Mcity infrastructure. They have a vehicle simulator, they have a pedestrian simulator, and they have a bicycle simulator. And what we really want to get to is a point where University of Buffalo can set up a human factors study. They can put 3 different participants, one in the vehicle simulator, one in the bike simulator, one on the pedestrian simulator, and they can then all interact within the digital twin world of Mcity. But the real stretch goal that we're going to work on with Humanetics, in fact, is to allow them from Buffalo in their simulators to control the robotic proxies that Humanetics has given us on the Mcity track. So somebody in Buffalo walking on a treadmill wearing VR goggles actually controlling the robotic platform moving around Mcity with the pedestrian dummy on it. So that'll be really cool. And like I said, you'll hear more about this afternoon. Professor Jose is a University of Michigan professor leading a team of students. They recently completed an NSF Cyber Physical Systems grant on advanced controllers. These correct by construction control synthesis methodologies. So basically using advanced techniques like opportunistic safety to deal with uncertainty, as well as leveraging predictive information like vehicle to infrastructure communication to make control more robust. So basically, they've done the work, they completed the grant, and now it's a chance for them to experimentally validate the work that they did. Need to get some water. Okay, so from MITRE, we have a project with Leila Ribeiro. And basically this is to figure out, can we leverage the public 5G for beyond line of sight control of drones? Or do you need something more like these quality on demand or network slice options? So this is work that's going to be run at the Mcity track where they'll be doing testing with drones and with different connectivity solutions to test the performance and then make recommendations to FAA. Here's a project that we're doing with Stellantis. Derek Fraser is their director of user experience work at Stellantis. And so we're gonna set up an actual class experience for students where students who are in the School of Information who are designing instrument clusters, center stacks, and all the bells and warnings that go off in the vehicle to tell you, to pay attention to certain things. We're going to be giving those students the ability to run a class project to put their designs into the VI grade simulator so they can actually see and run experiments with participants to see how well their designs work. And the specific case that we're going to be doing is the really hard human factors challenge when you get to SAE level 3, where the vehicle takes over control of the driving for the driver, but in certain cases, and sometimes these could be risky scenarios, like you need to do an evasive maneuver quickly, where the vehicle will say, driver, I need you to re-engage and take over right now, right? And so how do you do those transitions of control, right? So we're going to give the students that problem statement and say, design the user interface in order to do that, and then bring in human subjects for testing in the simulator to see how well their designs work. Texas A&M, Professor Pandey, we're working together on creating an end-to-end AI model for AI, for AVs. So end-to-end meaning, LiDAR data, camera data, textual information going in one end of the network, and a set of waypoints coming out the other end. What we're going to be doing here is actually leveraging a lot of our tools very directly in this work. The AI data engine we've created, also doing a lot of training work in the digital twin for this AI algorithm, as well as using the high fidelity sensor models that we're working with NVIDIA on. And then Ian Dodds, our VI grade representative, we've been working very closely with Ian. One of the big things with simulators is to make sure the experience is immersive, right? To make sure that even though it's a virtual experience, that people feel like, they are fully immersed in the world. And in some cases, we've done like we showed the teleoperation demo last fall, where we're actually using the simulator to control real world vehicles. So we've been doing a lot of work directly with Ian to improve the immersiveness of that simulator experience. And then ultimately what we want to do is VI Grade has Sim Center Detroit, which is in Novi, where they have one of their large full dynamic simulators. So think of it as a 6 degree of freedom hexapod that you're sitting in that's also on an XY sort of gantry-like system. So 8 degrees of freedom that the simulator can move in. And basically people can rent time on that simulator in Novi, and we're connecting it up to our Mcity infrastructure. So you could run your human factors experiment in Novi on their full dynamic simulator, but actually be controlling assets on the Mcity track. And then here's our project with NVIDIA, with Gautam Schollinger. Gautam and I are presenting this afternoon some of this work as well, so you'll hear some more about this. But the real work here is NVIDIA's put out this AV simulation blueprint, which we are implementing at Mcity. And the real goal of our work is to dramatically reduce the sim to real gaps, right? There's a lot of people in the AV space doing a lot of physical road testing, driving in the real world. And in large part, that's because they don't trust simulation because of the sim to real gaps. And so in this work, we're really going, very heavily after those gaps to close them. And a project with MITRE that we're doing that is analogous to the University of Buffalo project. So MITRE has a vehicle simulator, a scooter simulator, and a pedestrian simulator. So we're going to be connecting their simulators, which are basically in DC at MITRE headquarters, up to the Mcity infrastructure we have here. So again, similar to Buffalo, MITRE could bring in participants from the DC area, where we have a lot of interested constituents.
Could be legislative, could be executive.
Yeah, very well located. And human factors tests could be run at MITRE headquarters using the Mcity assets remotely. And Professor Gabor Oroz is running our 10th of 10 projects here that I'm going to talk to you about. And this is one that's holistically looking at teleoperation. So one of the big issues with teleoperation is latencies. So if you have somebody who's remotely in a center somewhere teleoperating a vehicle, what are all the latencies involved in that process? You know, you think about somebody in the teleoperator looking at a set of displays in front of them. So they have a certain reaction time. Once they see something, they have a reaction time. Then you have the latency of, you know, when they say, I wanted to steer this much, that has to be communicated to the vehicle. So there's communication latency. And then the vehicle has to receive that signal and react to it. So there is reaction on the actuation side on the vehicle. There's a latency as well. And then, of course, there's communication of the vehicle state back to the teleoperator. So there's a big set of latencies in that loop. And Gabor's going to be looking with his team at, you know, quantifying those latencies and coming up with corrective actions where needed. And that's my part. Any questions on the 10 initiatives that were taken on this year as part of Mcity 2.0?
Just a couple from me, Greg.
Okay.
You noted that you're starting to see a lot more usage of GPUs in most of your research initiatives. Is there any plans to expand with NVIDIA or any other like AWS wavelength expansion that you are going to be looking into? Because, you know, as these things progress, they're only going to get used more and more often. And, you know, I don't want to see your research be limited by the fact that you're physically being limited by the lack of compute power.
Yeah, it's an enormous pinch point right now.
Yeah.
It really is. It sort of breaks your heart to see the grad students fighting with each other, you know, because everybody needs to get their work done, right? But there's only so many GPUs to be leveraged. So right now, we just put in an order. Greg recently put it in.
Yeah, that DOT prize money is that Henry's won is going to another cluster. So we have, in addition to AWS, we have 2 clusters on campus that are supported by the College of Engineering that we paid for, but they pay the enormous electric bill every month for us. And we've got a 3rd cluster coming, and then we're definitely in discussion with NVIDIA on providing some additional clusters physically here. They've also given us access to their cloud clusters. I think are supported by AWS. I'm not really sure underneath what it is. But I'm trying to remember, that's 48 L40S.
Yeah, for
GPUs.
doing the high fidelity sensor simulation, basically all of the compute work for that is done on their cloud GPUs, NVIDIA's cloud GPUs.
Yeah, it's a super good question. I think what we've seen is any investment we've made in those kinds of resources has given us a 10x return already. Yeah.
Yep. Back to you, Greg.
Okay.